can't, you know, I do it on... There is a glare, which is why these two are closed. But I don't like being in a box where I can't see outside, which is why my door is always open, because I feel claustrophobic. All right, common factors. The first thing you always want to look for, right? Can I pull something out to make this easier? That really should be the first thing that you identify. Cubic. This is going to be new today. That's going to be new. We've done everything but cubics. All right, so the first ones are just going to be a little bit of review. First thing I ask myself is, can I? And can I? 3x squared leaves me with an x plus 15. Always ask yourself, yes, you're right. I just listened to Rachel without thinking. Okay, so, then we ask ourselves, can I factor it any further? Well, we're not going to be able to factor a parentheses whose highest degree is 1. It's already fully factored. And so sometimes factoring, if you remember, means just pulling out that common factor. Okay? All right, box method when you've got 3 terms is the nicest way to go. X squared 6, product of 6, that gives me 5, would be what? See, then I always want to jump to that 2, but 6 and 1 gives you 7. 2 and 3 gives you a sum of 5. So 2x, 3x. So pulling it up, we're going to get out of 2, an x, an x and a. So my factors are x plus 2 and x plus 3. The question will not say to factor, the question will say to solve, and the problem will have equals 0 on it.
That's when we come up with 2 answers, right?
All right, which format does C fall under? Is it a regular polynomial, a perfect square, trinomial, the difference of 2 squares? Yeah, do we all see that as a pattern? We need to kind of start recognizing that. 4 is a perfect square. X squared is perfect square. 1 is a perfect square. And I'm taking the difference between the two, so I'm subtracting. So what's nice with that is if you can recognize that as your pattern, you can right away jump to factoring those cleanly without doing the box method. If you feel more comfortable with the box method, do it. But what you should realize is that when you have the difference of perfect squares, you have conjugates. 4x squared is 2x and 2x. 1 is 1. 1 is positive and 1 is negative, and I'm done.
Why do you know one's positive and one's negative?
Because I can't have a middle term, Emily. So the only way to get rid of that middle term are to use conjugates. So I'm going to get a negative 2x, and then I'll get a positive 2x when I do my middle term, and they drop out. Okay, remember conjugates are one's positive and one's negative. A, this was a pull out, common term or common factor. And this one was just your traditional polynomial, right? Okay. Now, this is a polynomial, but which one is this that's special? It's possibly a perfect square trinomial. And we figure that out by looking at the first term, which is a perfect square. Would you agree? The last term, which is a perfect square, correct? And so when we divide these up, we don't use conjugates the way we did in C. We say x and x, 7 and 7, but we want that middle term. And it has to be negative. So what do the signs have to be? Both negative, right. We can't make them both positive because our middle term wouldn't be negative then. Does that make sense? And this, how would we simplify this down? And if I ask you to solve, Pooja, yes, I would have one answer. So that would be a parabola that just touches the x-axis.
So the perfect square trinomials will always be like x minus or x something that's squared.
Yes. Yes. Okay. All right. So what am I going to do in E? So 4z squared leaves me with z squared minus 4z plus 4 So we're doing two things here, and then what do we have? Do we have a perfect squared trinomial, or do I just factor this like normal? I possibly have a perfect square, right? Because z squared is perfect and 4 is perfect. So let's see. That means z and z, 2 and 2. Middle term is negative. Last term is positive. What's my sign going to be? And then check. Middle term is a negative 2z and a negative 2z, which actually is the negative 4z. So this works. What do I need to make sure I include as part of my answer? Good. You guys are getting this. So 4z squared, z minus 2, z plus 2. Nah, sorry. I'm sorry. I'm not thinking. Right? So 4z squared times z minus 2 squared. All right. What am I going to do here? 2y to the third leaves me with y to the minus 9. What am I left with? What's my pattern for this one? Difference of perfect squares. So that's 2y cubed and y. Always, always, always check to make sure that you didn't factor it all, that you did factor it all the way down. Yes, ma'am. Then it can't be factored any further. I could have y squared minus 8, and then I'd just be done. I know that I've got conjugates. Is that better? Okay. So, factoring the sum or difference of 2 cubes. 2 cubes means I have 2 terms. Each term is a cubed. Like 8 is a cubed, right? It's 2 times 2 times 2. 27 is a perfect cube because it's 3 times 3 times 3. Okay? A to the third is a perfect cube because it's a times a times a. Is a to the sixth a perfect cubed? A to the sixth. Is that would be a to what power cubed? Yes, because remember your rule is raising a power to a power. It is. A to the sixth is a perfect cube. Okay? I'm just saying, is a to the sixth a perfect cube? The answer is yes, because it can be written as a squared to the third power. We're not plugging anything in. We're looking at our terms and deciding if they're a perfect cube or not. So a to the ninth would be, can this be written as something to the third? A to the third raised to the third is a to the ninth. It's a perfect. What about a to the seventh? No, because I can't write that as a to some value to the third. Doesn't work, right? So do we understand what cubes are now? Okay. So there is a common term that we use that I like to use. It's called SOAP. We all need soap. We all use soap every day. Soap helps us align our plus and minus signs in our parentheses. SOAP tells us the order of our signs. S stands for the same sign. O stands for the opposite sign. And AP, always positive, goes together. So I'll show you. I don't expect you to. You've never seen it. Okay? So, if I give you a cubed minus b cubed, we're going to keep this really simple. Okay? And I know that this is a perfect cubed because my first term is cubed. My second term is a cubed. I only have 2 terms. Okay? I don't have 3 terms. This only works with 2. So here's how we set up our signs. We do two sets of parentheses, a small one and a big one. And we set up our signs first. Okay? First parentheses, same sign. If this is negative, this one's negative. We're using soap. So the first sign has to be the same sign as the problem.
Wait, this is a factor cube.
It's a factor cube sign. All right, the next sign is the opposite sign of whatever was originally here. So if this is negative, then our next sign has to be, and then the last sign is always, so we're going to have so. Now we're going to fill in the spaces. Yes, that's why I made it big. All right, so we're going to take our first term. We're going to take the cubic root of a cubed. What's the cubic root of a cubed? Okay, that goes here. So if I asked you the cubic root of 8, you'd put 2. If I said the cubic root of 64, you'd tell me 4. Okay? Right, it's what did you cube to get a to the 6. Okay? All right, then we're going to take the cubic root of b cubed. What is that? That goes here. Okay? You with me? All right, then we're going to skip to the middle step. This is multiply these two together. A, B. Multiply together. Now, just like completing the square, once you get the pattern, it's not hard. It's finding the pattern, though, that makes this tedious. Okay? All right. What we do here is we take that value and we square it.
Which value?
Our first term. So use your arrows.
Put that way.
And you put it right here. So this is a squared. Plus AB. And then what do you think we're going to do with the last term? We're going to take, now we don't worry about the signs. It's just that term. Don't worry because the signs are taken care of by soap. So we take our B and we square it and we put B squared here.
So we're pretty much assuming that all these numbers are positive.
Yeah, you don't worry about positive or negatives after you've placed them in your parentheses. How we doing? You can only factor cubics because they only have 2 terms, if they have 2 terms. Okay? All right, so let's look at these problems. First question should always be still. Can you pull anything out? So in this first one, can I pull anything out? No. So I know that this is a perfect cube because W cubed is a perfect cube and 27 is a perfect cubed. Okay? So the first thing you do is you set up your parentheses. You make them nice, the second one nice and big, and you fill in your signs.
Oh, and that's it?
Yeah, that was it.
Oh, really?
Yeah, that's factored. Okay? All right. So using soap, what should my first sign be? Same. So whatever the problem is, that's what this one is. What should my next one be? And what's this one always? So we've got our sign set up. Does that make sense? All right. So now our next step, take the cubic root of that first term. What's the cubic root of W cubed? That goes here. Right? Take the cubic root of 27. That's 3. That. Well, so what times what is 27? Exactly. So you should have some of these in your head. You should know that 1, 8, 64, no, 27. I'm not going to make them ridiculously huge, but they'll stay within the first ones. 1, 8, 27, 64, 125. Those are your first few perfect cubes, right? 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. I won't go much bigger than that.
How do we put this into our calculator regardless of?
Well, let's do this and then I'll show you later on. Okay? Negatives don't matter. We've already placed our sign. So now we're just looking at the number. So ignore whether it's positive or negative anymore, okay? Okay, so the 3 goes here, correct? What's my middle term? 3W. It's the product of the W and the 3. We don't worry about the sign. This middle term, see? Middle term, multiply together your first and last term in your parentheses. Okay? What's going to be first term here? What's going to be last term? 3 squared. But what is 3 squared? 9. So we're going to write 9 down. And we're done. That's it. We factored it out. No. Okay. What's the first thing we ask ourselves? Can I take anything out? What can I take out? I would take out an 8. And that leaves me with x to the 6 plus 8. Okay, is x to the 6th a perfect square? A perfect cube? So x to the 6th is equal to what raised to the 3rd power? Yes. So this is where it gets a little tricky, okay? You've got to recognize. So the cubic root of x to the 6th is x squared. Right? What am I raising to the 3rd power to get x to the 6th? X to the 2nd. Are you following me? Okay. We're going to set up our parentheses. Same sign. That makes this what? Opposite sign? Always. Okay. So, we took the cubic root of x to the 6th and got 8, and the cubic root of 8 and got 2. What do I put here? Yes, x squared. What do I put here? 2. What do I put in the middle? 2x squared. Okay, now, this spot here, we take x squared and we square it. So x to the 4th. Are you following this pattern? What's my last step? 2 squared, which is 4. Rachel, do me a favor, close the door, please. Thank you. Are we good? Anybody got a question? All good? Okay, let's move on. What can I pull out? And? Oh, no one caught my mistake. What did I forget to finish up by putting on my answer? I can't forget the fact that I pulled out that 8. So put that 8 there as part of what your answer is going to have. Okay? Doesn't it? 2? Okay. I'm just going by what you're saying. So then that gives me 8b to the 3rd plus who? 343b. No b. 343. Okay, it's a really big number. Okay. Okay. So 2b squared, open our parentheses, and you set up your signs.
So you're getting 2 because you're doing the cubic root of 8 in the end. Oh, wait, never mind.
Okay. So, same, opposite, always positive. Did you set up the signs right? Okay. First term. Take the cubic root of 8b cubed, and what do I get? 2b. Exactly. 2b or not 2b? So that goes here. Because I'm taking the cubic root of 8 and the cubic root of b cubed, because that's all part of that first term. Right? Okay. Cubic root of 343. Go to math. Maybe you do second math. And you see that little cubic root button? So whatever that one is. So what's the cubic root of 343? There you go. Now you know how to do it on your calculator. Okay? So that goes here. Would you agree? All right. What goes in the middle? Good. It's 2b times 7, which is 14b. Very good. What's my next step? Yes? Yes? Sure would. Perfect. And your last term is? And we're done. Okay? Are we getting this? Okay. All right. What do I pull out on this next one? Negative 2d squared. So, I pull out a negative, I'm looking for some room here. I pull out a negative 2d squared. I'm left with my parentheses. You try this one. First thing you do is set up your signs. So if you pulled out negative 2d squared, you've got d cubed minus 125. You really can't skip steps if you're going to want to get these right. You can find one. The other class do it? I think they've already done this. In general? Oh, I didn't know if you'd talked to someone in the other class and they're like, oh. Did they find it pretty easy too?
They thought it was like difficult. But I don't know, they're like, they never understood anything in that class.
So do you explain it to them?
Yeah.
Good. All right. Help them out. Same, opposite, always positive. You're taking your signs from the fact that we pulled out the negative 2 and we've got a negative in this parentheses, right? Well, yeah. If we pulled out the negative, we're looking at this as our cubic right here, and that's determining how we set up our signs. Is that making sense? All right. Yep. And your last one is 5. And your middle term is? And your first term here is? And your last term? And you're done. I think that was it, isn't it? Is this day 2? No. One more thing. 4 terms are easy. You do. You chunk them. If you've got 4 terms, you chunk them. You do the first 2 and the last 2.
So how do you combine them? Do 4 parentheses?
No, hold on. Hold on. Hold on. First 2 terms, what do they have in common? So pull it out and just worry with the first 2 terms. What are we left with? Okay, so when we do these next 2 terms, I need x minus 3 there again. Nope. Now, cover up the first 2 terms. What do I pull out of negative 16x plus 48 so that I have an x plus negative 16? Well, I know that my sign that I pull out has to be negative because I'm going from my last term being positive to my to this being negative. Okay? So again, we look at our first 2 terms and we look at last 2 terms. Okay? What do I pull out of the first 2 terms? Just the x squared. And that leaves me with x minus 3. If I were to FOIL this again, I'd still get x squared minus 3, x cubed minus 3x squared. Okay? I look at my last 2 terms. What can I pull out of that's common with negative 16x and 48? A negative 16. And that leaves me with x minus 3. If I FOILed this negative 16, I'd still get these last two terms. Does that make sense? I create this to be x. I know this has to be x minus 3 because that's what I got over here. Nope. It has to. So I'm going from 1, 2, 3, 4 terms. Would you agree? To this is one term and this is one term. Would you agree? So I've separated. I've gone from 4 terms to 2 terms, correct? What's common in both of those terms? So I'm factoring again the fact that it's common x minus 3. What's left in my first term? And what's left in my next term? And then we always ask, can I factor further? Can I factor x minus 3 further? Because it's linear. Can I factor x squared minus 16? What is x squared minus 16? Yeah. So it would be all 3 of those parentheses. I think you did too. You can only do this type of factoring if there's 4 terms. So this x squared gets put right here. Because see, look, now what I have in common in my 2 terms is the fact that I have an x minus 3, and I'm factoring it out. And that leaves me with x squared in my first term and negative 16 for my second term. Is that better? All right, let's chunk these. Okay, what do I have common in my first 2 terms? Pull it out. What am I left with? That means I need an x plus 7 for my last 2 terms when I pull out what's common. What can I pull out that leaves me with x plus 7? Negative 9. No, I don't think I'll. No. So what's common in both of those terms? What am I left with? And what do we call x squared minus 9? And name-wise, it's called the difference of perfect squares. Are we good? Emily, does this make more sense now after your initial, what?